So let me leave this one here, convert this one to a markdown, then call it KNeighbors. All right. Maybe make it bold. All right. So the same way I'm going to get this from sklearn.actually.neighbors. I'm going to import. Let me just get this. I'm going to import this. And then I'll use what is called the K-fold. So from scikit-learn.selection, I think there's a problem with spellings today. We are going to import what is called the K-fold. All right. Then we're going to use grid search. CV. All right. You're actually going to try different parameters here, so that we will get the best. Actually, what we want to do is let me add. Okay, let me just do the final one here for you, so that's when I'm doing these parameters, it will make sense for you instead of starting with the parameters. So I can name it as KNN. All right. So KNN equals this. I'll initialize that. All right. Then I want the n neighbors. That's the number of neighbors. All right, the number of neighbors. And then I don't know what I will initialize with, so let me just leave it. Let me just give a space here, and then I'll also want something we call a P, but I don't know the value to give. And then I'll also want the leaf size. All right, I want the best n neighbors. I want the best P. I want the best leaf size. All right, so in order to get this, I'm going to try different parameters of these neighbors. All right, of KNeighborsClassifier. All right, so let me just put them in. I think this will be better. If I just create a variable like this, and that's called create, something like that. Let me just create some form of a dictionary for this. So the leaf size, since I don't know, I'm going to try different ones. All right. Maybe I'll try 2. I'll try say 5. Try 7. I'll try 9. I'll try 11. Then the n neighbors. All right. The n neighbors. Let me try the same. 2, 5, 7, 9, and then 11. All right. And then for the P. For the P, I can try 1, 2. All right. And then I can initialize this grid search CV. All right. So if you don't get, if any of these making a bit difficult for you, you can easily search this gray search CV. You can go to the documentary and then you can see the parameters in there, and you will get to understand what leaf size, what neighbors, what P means. All right, you can easily get it. So let me just create this one here and then initialize it with gray search CV. And then in that, I'm going to try this KNeighbors with all these different leaf size and neighbors and P. All right. And then the param grade in small. Param grade. I'm going to use the param grade that I created. Alright, I'm going to use the param grid that I created. Okay, so after that, then I'll use my grid to fit. Dot fit. Underscore is train. Then y underscore train. Y underscore train. All right, so let's try this and see. Let's see what pops out. No model named sklen.selection.model selection. Okay, so from sklen.model selection, we're importing this, and then we are trying different parameters here. All right, different hyperparameters in grid search. All right, and then using KNeighbors because we want the best parameters to be using to build our algorithm. All right, so we try different leaf size and different neighbors and different P's to see which one is better. So this is what we call the parameter tuning. All right, we are just tuning the parameters to see which one is better before we use it. So we are not just straight away just using maybe any of them, maybe 5 or 6 will work, or maybe P1 will work, and then leaf size say 10 will work or something like that, or 20 will work. Correct. We are not using any random variables. We are actually performing a grid search to use different parameters and iteratively try to find which one is best for us. All right, so before we actually build this, let me bring another one here. Now we can actually get to know which parameters are doing well by using our grid here, which is the grid search CV object that we created. So we use this dot, what is called the best underscore param. All right, params underscore. If we use this, right, the grid. Okay, now this one is telling us, right, so if we use the best param, right, best params is now telling us that if we use the leaf size to be 2 and we use the neighbors to be 2 and we use P to be 1, we will get the best model that we want. So over here, neighbors, I'm going to use 2, P I'm going to use 2, P is 1, right? Say that we should use P to be 1, and then the leaf size we should use it to be 2. All right, so this is the best parameters that we are supposed to actually use. Okay, so I can close this up a bit. All right, so let's run this, and now we can actually use this to fit the model. All right, we can actually use this to fit the model. Okay, so let me just write it over here for you. Let's say call, let me use call K. K-neighbors algorithm. All right, and then we can use the KNN dot, then we use it to fit. All right, so I'm going to use this KNN. All right, we use it to fit the X train, X underscore train. All right, and then the Y underscore train. All right, so that's all we want here. Now we're using the leaf size to be 2, neighbors to be 2, and then P to be 1. All right, so after that we can actually make some predictions. So let's call that KNN underscore say prediction, or maybe pred is fine. All right, just shorten it to that, and then we use our model, which is KNN. All right, so we use in caps KNN dot predict, and then we use our testing data. All right, we use our testing data here to make some predictions. Now let me just run this one so that we get to, or maybe run it here so that we get to know these are the predictions that it is making for us. All right, so let's try confusion matrix for this also, and then we can actually get to have a visual representation of this. So for that, let me go up here and then use the same thing that we're going to use here and change whatever we're supposed to change. Okay, so over here, instead of this, right, I'm going to use KNN underscore pred. All right, and that's all we need to change. All the rest are this is Y test, and then this is what we use to write and then get the confusion matrix. So the only thing that we're supposed to change over here is this this predicted object. All right, okay, so if we undo this and then if we run, now see that we have this. Now you can see that we have 0 0 here, no mistakes. So algorithm, this K nearest neighbor is actually making 100% accuracy here. All right, it's predicting all the zeros as zeros and predicting all the ones as 1. All right, so let's move on and then try let's try to print the accuracy of this. So I'm just going to use what I used earlier on over here. All right, I can use this. Then instead of RFC, I'll use KNN. And then when I come here, I'll come and change it to KNN. And then here, classifier, I think I use, let me see what I used to make the fit. All right, I just use KNN, so I'm going to use KNN over there. Okay, now if we do this, see what we have over here. And if we see the average over here, if we check the mean, let me just go and use the same thing and make the necessary changes. If I use KNN accuracy here and see the mean, see that's almost 100%, right? If we find the mean over here, have almost 100%, and that's why we're not actually making any mistakes over there. It's more like 100% over there. All right, now if you're a bit familiar with neural network, then you can use what is called the multi-layer to also do this. But if you're not familiar with it, don't worry, you can I'm going to use that package, and you can easily check it out from the documentary, or when you read a little bit about neural network, then you can actually do that. So it's just an additional part that I just want to write it there for you, so that's where you can easily get it. And I'll give you a link where you can easily read that package and then get to understand it better. All right, so I'm just going to just add that one, so that you can also have an idea of something like that we can actually use. So I'm going to use what is called a multi-layer perception. As I said, if you're not familiar with neural networks, it's okay. I mean, don't worry about this. All the classification algorithms up there are okay to classify this problem, and this is just an additional that I'm adding for you. So if you're not familiar with it, it's okay, but you can actually read about it from the documentary, the documentation site, and I've also I'll give you a link here so that you can easily get to read about it. All right, so let me just quickly put it down here for you. Oh, come on. So from sklearn, I'm going to actually get this neural network. All right, I'm going to import the MLP classifier. All right, that is multi-layer classifier, right? Multi-layer perception classifier. Let me just initialize it to this multi_classifier, and this is going to be initialized to this. All right, let me give a bit of space here. Oh, these are just some hyperparameters that you can easily read about it. So I'll insert a link here if you're not familiar with the neural networks, so that you will not stress yourself searching for this. Right, but it's not actually any big thing. It's also a classification model that I'm using here. All right, so max iterator, I'm going to use I can use, let me use some crazy 8000, and then for alpha I'm going to use very small alpha, and then the solver, I'll use this. All right, and then bubbles, and then I'll set a random state. Let me just choose 21. Then I'll use tool to be very small here. Maybe say so let me use something like 1 2 3 4 5 6, something like that. Or maybe add something more. think I need one more bracket. No. Okay. Okay, so I'm going to use this to actually make the fit. So this becomes actually my model here that I'm going to use to fit. Extrain. Try that and see. Hidden layers, I know it. Come on, delete that. And then give me what is called hidden. Good. Okay, hidden layer underscore sizes. Come on, got to. And got an unexpected argument, verbose, and no spellings will cause trouble here. Okay, now all good. Now the trouble that is going to come is that I set this max iterator to be very huge, which is 8,000. Going to run that. Here, if you can see over here, is going to iterate up to that amount. Alright, so what I'm going to do is to probably pause this. Is going to run and run. If you can see, the Python 3 here is still running, and if you can see this small dot over here, you can see that it keep pushing up. So this keep on running and running and running, just iterating. Right, I gave it to be 8,000, which is very, very huge. All right, so what I'm going to actually do is to okay, now we're done. I think it's better now. So I'm going to do the same thing as I did for the other algorithms. I'm going to check for the accuracy and make some predictions and check for the accuracy. Alright, so let me try and then print a confusion matrix for the same thing as we did for the other algorithms. So if I do this, and then instead of KNN, I'm going to use Multi-Classifier. No, initially we have to actually do some predictions. So let me do that. Okay, so we're going to do the same thing as we did over here. Going to create this over here. So this becomes a multi, right? This multi predictions. And this becomes a multi-classifier. Okay. So let me run that. Now after that, I'm going to use this so that I can draw the confusion matrix, and that is all we need, right? Let me run that again and run this. Taking a little bit of time. All right, if you can see, Python 3 over here is still working. It's taking a little bit of time. So whilst it's taking time, let me just also do this. Let me print all the algorithms and the accuracies over here. All right. Let me convert this to Markdown. Maybe printing each, that will work. Printing each algorithm. in the accuracy score. All right. So let me do, or maybe I should just bold in it. Okay, it's still working, but it's taking a lot of time to do that because we have around 8,000. All right, so let me just do this pretty quickly so print. The first one was logistic. Our first algorithm was logistic regression. All right. Okay, now finally it's done. All right. Now you can see that we were able to, with this multi-layer perception, it's also predicted 160 as 0, all of the zeros as zeros, right? We're able to predict all the zeros as zeros and all the ones as ones. All right, so if you can see all the dark regions, they are represented as zeros, right? Showing that there was no misclassification in there. All right, so what I'm doing here is actually printing everything. All right, so for logistic regression, I'm going to bring it here. Logistic regression, accuracy. Let me see, did I do this metric? Okay, so I can even use this mean accuracy here. I can bring this there. And then I'll just duplicate this for the others. Okay, let me do it for this. The second one was support vector machine. All right, for support vector machine, and remember we tried a different kernel, right? So let's use where the first kernel equals 11 linear. All right, so for that, let's go and get it. Still make it more longer. Maybe I should just make it SVM1, and then here I'll change it to this. Okay, so so this is actually support vector. So remember support vector machine, we did it for 2 different hyperparameters, right? Where we did for linear, where kernel, right? We did kernel equals linear, and then we also did kernel equals RBF. Right, so let me go and bring the RBF one. So this is the RBF. Okay, so over here, we did not actually calculate the accuracy score for this. Yeah, it was 100%, so we did not actually do that. All right, so I can just explicitly state it over there. All right. So in this case it was 100%, so I can put it over here, and then let me just copy this, then put it here. So the next one after SVM, where we use the RBF after that, let me see which comes next. I think it's RandomForest. All right, yeah, it's RandomForest. So we're going to need this. Let's go down. We're going to need that over here. So that is RandomForestClassifier. All right, and then the next one was KNeighborsClassifier. All right, so let me duplicate this, then over here I'll use KNeighborsClassifier. Then for that, for KNeighbors, we have okay, so KNeighbors did not also make any mistake, though we did not do the accuracy score for this, but okay, it's here, right? I think KNeighbors is here. So we would like to use the mean. And then the last one, let me duplicate this again. The last one was linear. All right. So for this, it's making 100% also with no mistakes. So I can explicitly do that by just putting there that. Okay. Okay. So what I can do is I can probably do dot format this, that. All right, and then I'll do this. All right, so this is what we have for all of them. All right, so we have, let me put the percent signs here, also here. All right, okay, good. So this is what we have for the algorithms, and over here we can see that Logistic Regression is making 98%. Support vector machine with KNN equals linear is making 98. With KNN equals RBF is making 100%. And so you see that we're just changing the KNN. You see that our model improved, right, by about 1.5%. All right, so you can actually hyper tune the hyperparameters, all right, and get a better accuracy for your model, right, rather than maybe changing the algorithm. Okay, now you can also see from the RandomForestClassifier that we are making 99%, and K-neighbors, we are making actually this supposed to be multi-layer here. All right, it's supposed to be multi-layer perception. All right, and then we have 100% for multi-layer perception. So in this case, you can actually look through and then choose the better model, right? But what I urge you to do that from this point is also change the hyperparameters that we are doing. We've been using for building this algorithm, right? For instance, we use 80 for training, and then we use 20 for testing. You can change that to say 70 for training and then 30 for testing. All right, and you can also change all the hyperparameters that I have been tuning in this this kind of practice. You can also be changing the hyperparameters and then try to see whether your algorithms will, whether the accuracies of these algorithms are going to change or even going to improve more than we are having right now. All right, so try different hyperparameters, try tuning different hyperparameters, and read a lot of in the documentary, in the documentations. All right, read a lot in the documentation also. So all right, see you in the next project. Have a nice day.